Hello, and today's learning target is I can identify a geometric sequence, find the common ratio, the zero term, and the next three terms. So let's talk about what a geometric sequence is. A geometric sequence is a sequence where you multiply by the same number every time. So similar to arithmetic sequences, there's a common pattern that we see, but this time it's not adding or subtracting, it's strictly multiplying. So I'm going to highlight that word as well. So let's go through and let's identify if the following sequences are arithmetic, geometric, or perhaps they're neither, so there's no pattern that can be seen. So 2, 4, and 12. Well, between 2 and 4, we're adding 2 or we're multiplying 2, right? But between 4 and 12, we are not adding 2 or multiplying by 2. So since there is not a common pattern between all of these numbers, this is neither arithmetic or geometric. The next example, 3, 6, 9, we are adding 3 each time. So this would be arithmetic. And with this third example, from negative 2 to 8 and 8 to negative 32, it appears that we are multiplying by negative 4. So because we're multiplying by the same term each time, this is geometric. Okay, let's move on. So given the geometric sequence, identify the common ratio, the zero term, and the next three terms. The common ratio here is what we are multiplying by between each number. So what is the pattern? That's called the common ratio. Similar to the common difference of an arithmetic sequence, this is now the common ratio. So between 2 to 4 and then 8, we are timesing by 2 each time. So my common ratio is 2. My zero term, similar to what we did with arithmetic sequences, is we need to figure out the term that's written or provided before this first term, right? So we have to essentially work backwards and say, what times 2 is 2? Well, what times 2 is 1, and if we didn't know that, we could take 2 and divide it, so our first term, and divide it by the common ratio of 2, and 2 divided by 2 is 1. So again, if it doesn't jump out in your head that what times 2 is 2, that's 1, then you could always work backwards. So start with your first term, divide it by that common ratio, then to work backwards. So the zero term is 1. The next three terms, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64. All right, let's continue on. Negative 2, 6, and negative 18. So what is happening between these terms is multiplying by negative 3. So the common ratio is negative 3. And now here I have to find my zero term, so I need to work backwards. And if you'll notice, we will actually get a fraction. So I'm going to divide negative 2 by negative 3 to get my zero term. And let's rewrite that a little bit better. And negative 2 divided by negative 3 is 2/3. And I'm going to leave that as a fraction. I'm not going to change it to a decimal. So the zero term is 2/3. Then the next three terms, negative 18 times negative 3 is 54. 54 times negative 3 is negative 162. And then negative 162 times negative 3 is 486. So geometric sequences can get large really fast, or on the other end, they can get small really fast, and that's because we're multiplying by the common ratio between each term. All right, so given the geometric sequence, let's continue to identify the common ratio, the zero term, and the next three terms. So I see 24, 12, and 6. So I am dividing by 2 each time, or instead of saying dividing by 2, since I know that geometric sequences need to be, each term needs to be multiplied by a common ratio each time, I need to change that division of 2 to a multiplication problem. So instead of dividing by 2, that's the same thing as multiplying by 1/2. So the common ratio is 1/2. The zero term, if I work backwards, right, what times 1/2 is 24? Well, you could think about on the other end, what even divided by 2 is 24. and that's 48. And again, if you didn't know this, you could always work backwards and in your calculator or in your head, take 24 and multiply it by, 24 divided by 1/2. The next three terms of the sequence would be 3, 1.5, or 1.5, and then 0.75. All right, let's look at this next example, 32, 16, and 8. Very similar to the example we just saw, right? We're dividing by 2, but the same thing as dividing by 2 is really multiplying by 1/2. To find the 0 term, I'll work backwards. And what times 1/2 is 32? Well, or what even divided by 2 is 32, and that's 64. The next three terms would be 8 times 1/2 is 4, times 1/2 is 2, and times 1/2 is 1. Now with multiplying by 1/2 every time, a good question to think about is, we're getting these numbers smaller and smaller, 4 to 2 to 1. Will that ever get to 0? Could this sequence ever eventually get to 0? That's something to think about, and we will talk about that in class as well. Okay, let's look at the next example. 5, 25, and then 125. I am multiplying by 5 each time. So my common ratio is 5. The 0 term, if I work backwards, what times 5 is 5? That's 1. Then my next three terms are 625, 3,125, and 15,625. All right, and let's look at this last example. Between -3 and 3, that's multiplying by -1. Between 3 and -3, that's multiplying by -1. So my common ratio is -1. If I work backwards to find the 0 term, what times -1 is -3? That'd be a +3. And the next three terms are, well, what comes after -3 is 3, then -3, then 3. So it's kind of a different sequence that we've seen for this example than the others, but that still is considered a sequence. Thanks for listening and have a great day. Bye-bye.